Alright guys, this video is going to cover percent yield. Percent yield allows us to express the ratio of how much product we should have gotten versus how much we actually obtained. If you look at your equation, this is on your formula charts. The actual is how much we actually got. That should make perfect sense. The theoretical is how much we should got. So it's just a proportion. Simple division problem, you're getting a percentage. You're going to get that, it's going to give you a decimal, multiply it by 100. Important things to know is that percent yield can be above or below 100. Very rarely will you get 100% yield, and a lot of this goes, a lot of this depends on the actual atmospheric conditions and the weather for that day, believe it or not. Because of all the water in the atmosphere and high humidity, heat, all these things kind of go and affect your actual output when you're doing an experiment. But all you're going to be really required to do is to calculate it. So here's your example. The reaction of combustion of octane is known to be only 74.3% efficient. How many grams of water should you actually expect to form if 90 grams of liquid octane are burned? So we're going from 90 grams of octane, which is C8H18, we're going to find grams of H2O. So we're going to start with our given, 90 grams of C8H18. We are in grams, so we're going to use molar mass as a conversion factor, which is 114.26 grams in every 1 mole. The next step is the mole ratio. We have our mole of our given, which is 2, to our moles of our destination, which is right here, 18 moles of water. Now we convert away from moles. We have 1 mole of H2O. We're going to grams of H2O. So we're going to use a molar mass of H2O, which is 18.02, one you should have memorized by now. Do that math, and that gives you 127.75 grams of H2O. Now that is your theoretical yield. That is not what the question is asking so far. So it says it's 74.3% efficient. Wow, 74.3 efficient. So we're going to take 74.3% of our theoretical yield. So 127.75 times the decimal percentage, which is just 2 decimal places to the left, 0.743. That will give you 94.91 grams of H2O. There we go. That's all that one was. The next practice problem, you're starting out with 35.6 grams of zinc sulfate. And those are actually produced when they have excess. And, okay, sorry, let me do this one. Okay, 35.6 grams of zinc sulfate are actually produced. So 35.6 grams are actually produced when we have 47.3 grams of aluminum sulfate. So we're going to go find grams of zinc sulfate. So 47.3 grams of aluminum sulfate. I'm just going to abbreviate with the aluminum. We're in grams, so we're going to do the molar mass of aluminum sulfate, which is 342.17 grams every 1 mole. Now you do the mole ratio. We have 1 mole of aluminum sulfate for every 3 moles of zinc sulfate. Now you convert away from moles, so 1 mole of zinc sulfate. We're going to grams of zinc sulfate. So you got to do the molar mass again. This time zinc sulfate gives you 161.48. Calculate that, and that gives you 66.97 grams. Remember, that's your theoretical. Now we're trying to find the percent yield. So we're going to take our actual, which is 35.6 grams, and divide it by our theoretical, 66.97. We're going to multiply that by 100. That will will give us 53.16% yield. That's all that was. It's a short video. Write down any questions, we'll talk about them in class.